ready to try this. I hope that you're all out there, and I appreciate that you are taking the time to do this. I know that you don't have to, so I really do appreciate your participation. So, to get on with our first real-time interactive lecture, remote interactive lecture, let's get started. So you'll see at the top of the screen that if you have a question, you can ask it at that URL. Google Interactive Slides presentation mode allows us to do this, and so we're going to use this for a little trial, and hopefully this will be something that I can incorporate into our classroom activities in the future. So your participation in this test will help future classes, so thank you for doing that. I am going to use that Ask a Question feature kind of in reverse. So I'm at some point going to be asking you questions, and I'm going to ask you to use that URL to submit your response. And then at the end of the presentation, if you have questions, you can use that URL to ask. All right, so introduction to binary. So you all know this, but we're going to revisit it, that there are a variety of numbering systems in existence, and they all share some common concepts. They all have some type of a radix or a base that the numbering system is based on. They all have their own symbols or numerals that are used based on that radix or base. They all use the idea of positional notation, which says that the value of that numeral or symbol differs based on its position in the number. They all use exponents or multiples of that base or radix. And they all have the same principles that apply to leading zeros and trailing zeros. Leading zeros, remember, are the numbers that are to the left of the number, and those zeros could go on for infinity. There could be innumerable leading zeros, and so we ignore them. Trailing zeros, however, are the zeros after the number or to the right of the number, and those are significant. We do pay attention to those. All right, so here's my problem that I always have. The most common numbering system that we have is the decimal numbering system, and it is based on the number 10. You know my theory about why we use this numbering system, and it may or may not be true, but we have 10 fingers, 10 digits, so this is probably the easiest one for us to practice on. But you are very familiar with this numbering system. You've been using it since you were a toddler. The numerals and the symbols that are used in the decimal numbering system are 0 through 9. And so when we talk about the decimal numbering system, you can see here the positions of those numerals are based on powers of 10. And so any number to the 0 power is 1. So whatever we place in that first column, we're going to be multiplying by 10 to the 0 or 1. And so on. The next position, the value of that column is 10 to the first or 10, and so on. So when we count in decimal, our first position, we can have 10 numbers. But once we get to the end of that, we have to move over one column, and those are our values for 2 digits. Now this will continue to go on and on and on until we get to 9s in this column, and then we move over again. And you understand that. So some examples of decimal numbers and what we actually are doing when we say 1964. It was a good year. When we say 1964, we're actually saying 1 times 1,000, or 10 to the third, and we're adding that to 9 times 10 to the second, and we're adding that to 6 times 10 to the first, and we're adding that to 4 times 10 to the 0. That's really what we're doing. And in this example, the same thing. We're taking 8 times 10 to the 6th, plus 6 times 10 to the 5th, plus 7 times 10 to the 4th, and so on. And you understand that. So, because you understand that, we should be able to take that existing knowledge and transfer it to another numbering system. And this numbering system that's important to us, at least in the networking and computation world, is the binary numbering system. And remember, binary is based on a radix, or a base of 2, and we only have 2 symbols, 0 and 1. And so the values of our columns, or our positions, are based on powers of 2. 2 to the 0 is 1, 2 to the first is 2, 2 squared is 4, 2 cubed is 8, and so on. And so these are the values of an 8-bit binary number. So when we count in binary, this moving over to the next column happens very rapidly because we only have 2 symbols, or 2 numerals, available to us. So we have 0 and 1 in the first column, and that's it. Now we have to move over. Now we have a 1 in the second column, and we have 0 and 1, and that's it. We have to move over. So this happens very rapidly. So here are some examples. And here's where I'm hoping I can get some interaction from you. So when we place a 1 in this column, a 0 in this column, a 1 in this column, and a 0 in this column, we can then calculate the decimal equivalent of the binary number 1010. So, does anyone know what the binary equivalent of 1010 is? And now I need to switch. There we go. I will wait. Oh, we do have an answer. We have 2 answers. Anonymous says 10, and so does Adam. Very nice. Oh, we've got more. Ben says 10 as well. I'm glad you guys are here. So, now we have a little bit more difficult one. The next practice is 1010100. Who knows the answer to that? There is not much delay here. Does anyone know? 1010100. Now maybe there's some delay. Oh, there we go. Adam says 84. Nice work. That is the case. Oh, now we have Ben. He says 84 also. Nice work. And Dylan says 84 as well. Good job. We're going on to the next page. I have more. So, how about 1111101? Who knows that one? There is maybe just a bit of a delay, but not a huge one. There's an answer. Dylan, here's a clue. If the last number is 1, it's an odd number. Adam, good. Ben, good. There we go. Good job. And the last one. Let's see who can be first to answer that last one. An 8-bit binary number, that's all ones. It's the maximum value for an 8-bit binary number. You guys are probably already answered, but there is a bit. There we go. Adam 1. Nice. And Dylan. And Ben. Good job, guys. So, that's all for my presentation, but do you have any questions for me? I'll wait just a little bit. If not, that's fine too. I thank you so much for participating in this test of our interactive remote lecture. I think it went really well. We'll see how the recording looks. Thanks, guys.